Okay, so this is our practice of the problems. Now, hopefully you've had a chance to try them. I noticed that when you type the answer in and hit check, it automatically grades it for you, so you can give it a good effort before you see the solution. But so anyway, after you've given it a try, or if you're stuck, we'll see if we can do this. So this is an example of part of a contingency table. It's not all of it. So I'm going to copy this and paste it over into our Excel here. Now notice, we've got a question here. What is the probability that we are of a random driver being a young accident risk? So to complete this table, we need to come up with the column and row sums. So I'm going to add those together. So there's our column sums. Here's our row sums. And if I add these two together, we've done it right. They should add to the same number, which they do. So you get 185 observations in our sample. We want to know the probability of a random driver being a young accident risk. So this is, first we need to know how many young accident risks we have. So these are the young, and these are the accident risks. We've got 17 of those. So we've got 17 observations that meet that criteria out of a population of everybody. So random driver, we're not restricting our sample in any way. We can use the full sample size. So it'd be 17 out of 185. And that means we have a probability of 9.2%. So if I paste that in here and check it, I can verify that this did indeed work. So now let's take a look at the second question here. We want to know the probability of a driver being risky given they are young. So I'm going to copy and paste again. So we need to get these column totals. Risky given they are young. So if we're assuming young, that means this is our population of interest. Right, so risky given young is probability of risky. These are the risky ones. We've got 93 risky ones that meet this criteria, right? These 59 risky observations are not young ones. So if we're assuming young, we don't need to worry about these. We just need to worry about these. So we've got 93. And that's out of a total sample of 146 young drivers. So if we're assuming young, we're restricting our sample to 146 drivers, 93 of which were accident risks, making this our total probability. We can check that. So now for the last two, we ask what's the probability of a random driver being a young driver or an accident risk. Notice now we've got 54 plus 87 drivers that are young, and we've got 54 plus 30 drivers that are accident risk. So being one or the other is actually going to be 30 plus 54 plus 87 divided by the total observations. You can also do the total accident risks plus the total young, but you have to subtract off the 54 because you double count it that way. Similarly, we can ask the probability the driver is young given they are an accident risk. So this would be in this population. So within this column, we would do 43 divided by 43 plus 93. So in short, that's how you handle part one. So when we continue, we'll look at extending this to dealing with, rather than counts of people, but being given probabilities in the first place.